Myself, Asha Somshekar Angdi, subjects chemistry, semester BSc second sem, topic name ionic bonding, definition of ionic bond, criteria to form ionic bond, general characteristic of ionic compounds. Ionic bonding. Firstly, we study definition of ionic bond. When the electronegativity difference between the two atoms is larger, they can attain stability in their electronic configuration by the complete transfer of one more electron from outer shell of one atom to the other and can be linked together by an attractive force as ionic bond. During the formation of this type of bond, one atom loses electrons while the other gains electrons. The atoms which loses electron is an electropositive atom, and while the one which gains electron is known as electronegativity atom. The metallic atom are usually electron positive while the non-metallic atom are usually electronegative. Thus an electron bond is generally established between a metallic and non-metallic atom. During the formation of an ionic bond, the electron positive atom loses one or more electron and changes into a cation, while the electronegativity atoms gains the electrons lost by the electropositive atoms and changes into an anion. They positively charged ions thus formed are held together by electrostatic force of attraction in the ionic bond and may defined as follows. Criteria to form ionic bond. Firstly, formation of an ionic bond between two atoms is favored by the following factors. First one, low ionization energy of metal atom. Ionization energy is defined as the amount of energy required to remove the most loosely bound electron from an isolated gaseous system of an element. The low value of ionization energy of the metal atom, greater will be its tendency to form cation and more easily will enter into formation of an ionic bond. Therefore, the metallic having low value of ionization energy possess great trending to form ionic bond. Alkali metals and alkaline earth metals possess relatively low ionization energy easily from ionic bond. Second one, high electron affinity of the non-metal atom. Electron affinity is defined as the amount of energy released when an electron is added to an isolated gaseous atom of an element. The electron affinity of an electron may be regarded as the measuring of its tendency to form an anion. Hence, the higher the value of electron affinity of the electronegativity atom, greater will be its tendency to form an anion and more easily will it enter into the formation of the ionic bond. Therefore, the elements with high value of electron affinity usually form ionic compound. For example, the elements belonging to group 16 and group 17 halogens usually from ionic compounds due to the high value of electron affinities. Third one, large difference in electron negativities. Higher the difference in the electronegativity of two atoms, greater will be the ease of formation of the ionic bond. In fact, the difference of two or more is necessary for the formation of an ionic bond. For example, the electronegativity of Na is 0.9 while the calcium is 0.3. Since the difference is greater than 2, they form an ionic bond. Fourth one, high value of latic energy. The amount of energy liberated is condensate. The required number of cation and anion to form the latic of 1 gram mole of an ionic compound is called the latic energy of the compound. It is denoted by U and measured of kg mole. The latic energy may be regarded as the measuring of case of formation and stability of an ionic compound. Higher the latic energy, greater will be cause of formation of the ionic compound and more stable will be the compound. The magnitude of latic energy depends upon the size as well as charge of the ion. First one, size of the ions. If the ions are smaller, the intermolecular distance is less and there will be greater intra-ionic attraction Consequently, the latic energy will be high. Hence, smaller the size of ions, greater is the latic energy. Second one, charge on the ions. The interionic attraction and hence the latic energy depends upon the magnitude of charge present on the ions. Higher the charge on the ions, greater in the latic energy. Then we study the general characteristic of ionic compound. First one, the important characteristics of properties of ionic components are discussed in below. We discuss in the below points. First one, physical state. Ionic compounds usually exist in the form of crystalline solid at room temperature. This is because strong electronic force exhibits between the positively charged ions hold them closer and 10 kk them in specified position in the crystal lattice. Second one, melting point and boiling point. In an ionic solid, the positively charged ions are highly held together in their specialized position by strong electronegativity force. It requires a very high temperature to overcome this force. This force, the melting points and consequently the boiling point of ionic compounds are generally very high. Third one, hard and brittle nature. The ionic solids are harder and brittle. Their hardness is due to the strong electronegative force exists between the ions. Their hardness increases with decrease in intraionic distance for crystal with similar structure. The order of hardness is alkaline earth metal oxide is size of cations. Hardness also increases the increase in charge on the ions for crystal with similar charge. Fourth one, solubility. Ionic compounds are soluble in water. This because water has highly dielectric constant and weakens the electrostatic force of attraction exists between the ions. The ions thus get separated and get surrounded by the water molecules. Organic solvent like benzene, hexene, ether, etc. possess low dielectric constant and are unable to weaken the electronegativity force of attraction. Hence, ionic compounds are not soluble in organic solvent. Fifth one, electric conductivity. Ionic compounds are unable to conduct much electricity in the solid state. This is because of solid state. The ions are fixed at the solid specified position and are unable to move. However, it fused state or in the form of solution, these compounds can conduct current because in the fused state or in the solution, ions are free to move. Thus, ionic compounds are poor conductors of electricity in the solid state but are good conductor in the fused state or in the dissolved state. Sixth one, reactions. The reaction of ionic compounds involves the mutual interaction of ions. These reactions are called ionic reactions and very fast reactions. And last one, seventh one, isomerism. Ionic bond is non-directional and rigid. Hence, ionic compounds do not exhibit isomers. Thank you.